All right, hey Global Impact, this is Mr. Ellinger. This lesson, our last lesson in Unit 3, is on arithmetic sequences. And what this lesson is going to do is it's going to allow us to take this general idea of functions and kind of extend it into our next couple of units where we're going to talk about linear functions. So our learning targets for this lesson are we need to be able to identify and extend patterns and sequences. We need to be able to represent arithmetic sequences using function notation. So some essential understanding for the lesson. Some sequences have function rules that can be used to find any term of the sequence. When the pattern in a sequence is identified, the sequence can be extended. Some background for the lesson. The study of sequences in this lesson lays a foundation for the study of graphing linear equations in the next unit. Finding patterns in sequences and using them to extend the sequence prepares you for identifying the slope of a line as a pattern in the line and using the slope to extend the line. Further, modeling arithmetic sequences using a function rule prepares students for writing the equation of a line. So a sequence is an ordered list of numbers that often form a pattern. Each number in the list is called a term of a sequence. When you can identify a pattern in a sequence, you can use it to extend the sequence. You can also model some sequences with a function rule that you can use to find any term of the sequence. So describe a pattern in each sequence below. What are the next two terms of each sequence? So here we have a sequence of numbers 5, 8, 11, and 14. So in this sequence, every term has a common difference of 3. So we add 3 to get 8 from 5. We add 3 again to get 11, and we add 3 again to get 14, and we could extend that pattern on as long as we'd like. So a pattern is add 3 to the previous term. So the next two terms after 14 would be 14 plus 3 is 17, and 17 plus 3 is 20. All right, in B here, if we take a look at our terms of our sequence, we have 2.5, we have 5, we have 10, and we have 20. So in this sequence, it should be fairly clear that we're not adding as we look from term to term. Okay, we are multiplying because, 2.5 doubled is 5, double it is 10, double it is 20. So doubling means times 2. So the pattern here is to multiply the previous term by 2. So if we continue that pattern, take 20 and multiply it by 2, we get 40. So that would be the next term. And then after that would be 40 times 2 would be 80, and we could extend that on out as long as we'd like. So describe a pattern in each sequence. Go ahead and take a second, pause and try these. What are the next two terms of each sequence? Okay, so on A, if you observe the pattern here, 5, 11, 17, 23, we are adding 6 every time. So the next two terms of that sequence would be 29 and 35. In B, the pattern in the sequence, we go from 400 to 200 to 100 to 50. We are dividing by 2 every time. Okay, another way to think of this is we would be multiplying by 1/2 every time. So the next two terms in the sequence would be 25. 50 divided by 2 is 25. And then 25 divided by 2 is 12.5. All right, in C, our pattern, we go from 2 to -4 to 8 to -16. So one thing that you observe here is that we go from positive to negative to positive to negative. And we go from 2 to 4 to 8 to 16. So there's a doubling that's going on here, but we also have a sign change. So what we do here is each term, the pattern is we're going to multiply by -2 is what's going on here. So the next term in this sequence would be positive 32. And then after that, times -2 would be -64. Okay, and in part D here, we go from -15 to -11 to -7 to -3. So what's going on here? You could say that we are adding 4 every time. Okay, -15 plus 4 is -11, -11 plus 4 is -7, and so on and so on. So the next term in this sequence would be a 1, and then after that would be a 5, and that would continue on and on and on forever. In an arithmetic sequence, the difference between consecutive terms is constant. This difference is called the common difference. So arithmetic the difference between terms is going to be a constant thing. So tell whether the sequence is arithmetic. If it is, what is the common difference? So in part A here, we look at our sequence. We have 3, 8, 13, 18. Common difference of 5 every time. So that we would call that an arithmetic sequence. In part B, we have 6, 9, 13, 17. Okay, still a sequence of numbers. There may be a pattern here, but it's not arithmetic because the difference between 6 and 9 is 3, and then after that we have a difference of 4. Okay, 9 to 13, there's a difference of 4. 13 to 17, there's a difference of 4. So we would not call this an arithmetic sequence. So tell whether the sequences are arithmetic. Let's take a look at A and D. In A, our sequence is 8, 15, 22, and 30. Okay, so here's a common difference of 7, common difference of 7, common difference of 8. Okay, so in part A, we have from 8 to 15, we have a difference of 7. 15 to 22, we have a difference of 7. 22 to 30, we have a difference of 8. So this is not arithmetic. Okay, right away, if we look here on part D, we go from positive to negative. So right away, that's a big clue that this is not arithmetic. The difference is 4, but it's like positive 4. This is a negative 4 difference, then a positive 4 difference, then a negative 4 difference, and a positive 4 difference, and so on and so on. Part B, though, I didn't circle this one, but let's take a look at this one to look at one that is an arithmetic sequence. We have a difference of 2, 7 to 9, 9 to 11 is a difference of 2, 11 to 13 is a difference of 2, so we would say that yes, this is arithmetic. And just to continue here, let's look at C as well. What's the difference between 10 and 4? That's a minus 6 difference. 4 to negative 2 is another minus 6 difference. Negative 2 to negative 8 is another minus 6 difference, so that is an arithmetic common difference. Okay, so a sequence is a function whose domain is the natural numbers and whose outputs are the terms of the sequence. So the inputs would be the actual term number, like first term, second term, third term, fourth term. You can write a sequence using what's called a recursive formula. A recursive formula is a function rule that relates each term of a sequence after the first to the ones before it. So the term of a sequence after to the first ones before it. Consider the sequence 7, 11, 15, and 19. You can use the common difference of the terms of an arithmetic sequence to write a recursive formula for the sequence. For the sequence 7, 11, 15, 19, the common difference is 4. So here's how this works. We let n equal the number of terms in the sequence. So n could be the first term, second term, third term, and so on. We let capital A of n, this is common notation for arithmetic sequence, okay, capital A of n, it's going to be the value of that nth term of the sequence. So the value of term 1, the first term in the sequence, is 7. The value of term 2, the second term, A of 2, is the first term plus 4. Okay, so it's the term before it plus the common difference. So value of term 3, which would be A of 3, is A of 2 plus 4, the term before it. And since A of 2 is 11, 11 plus 4 is 15. And if we continue on that pattern, we can make a generalization down here at the bottom that the nth term is A of n, and that equals A of n minus 1 plus 4. So the recursive formula for the arithmetic sequence above is A of n equals A of n minus 1. So this n minus 1 refers to the term before it. Okay, so a term is built off of the term before it plus the common difference of 4. Okay, so here's an example where we write a recursive formula for the arithmetic sequence. And so what I would encourage you to do right now is just to kind of pause this and take a look at this. You can write this down in your notes if you'd like. This gives you a step 1 and a step 2 on how we would develop the 8th term in the sequence. Okay, so you can find the value of any term of an arithmetic sequence using a recursive formula. You can also write a sequence using an explicit formula. An explicit formula is a function rule that relates each term of a sequence to the term number. So the explicit formula is based off of the term number, not necessarily the term before it in the sequence. So here in this concept box is an illustration of what the explicit formula is going to look like. So if we need to know the nth term of this arithmetic sequence, it's going to be the first term plus the term number that we're trying to determine minus 1 times the common difference. Okay, that's the pattern here. So here's an example of this. An online auction works as shown below. Write an explicit formula to represent the bids as an arithmetic sequence. What is the 12th bid? So this would be like a screenshot of a computer here. That's what we're seeing. So bid 1 is $200. Bid 2 is $210. Bid 3 is $220. Bid 4 is $230. Okay, so you can see that these bids are increasing by $10 every time based off of a minimum price or a minimum bid of $200. So if you've ever bid on eBay, this would be kind of like an eBay type situation if you've ever bid on anything on eBay. So make a table of the bids, identify the first term and a common difference. So term 1 would be the minimum price, the starting price, and that value is 200. So the first bid is actually the second term in the sequence, which is 210. Third term is the second bid, which is 220, and the fourth term is actually the third bid, the fourth bid, which is 230. Okay, so in here this is our common difference of 10. So if we substitute a of 1 equals 200 and the common difference of 10 into this formula, again, this is a formula, so we're just going to be substituting things into this formula. The explicit formula, a of n equals 200 plus quantity n minus 1 times 10 represents the arithmetic sequence of the auction bids. So to find the 12th bid, we just need to evaluate a of n for n equals 12. So evaluate the function a at 12. We're going to take 200 plus the quantity 12 minus 1, which is 11 times 10. 11 times 10 is 110. So 200 plus 110 is 310. So the 12th bid is 310. Okay, and again, this right here is a formula that allows us to determine any term in the sequence. If we know the first term and we know the common difference, then we can find any term we want. Okay, so, we're not going to do a whole lot with sequences, but it is important to kind of see, understand patterns, common differences, because that's going to springboard us into our next couple units where we're going to work with linear functions where things increase at a constant rate. It's going to help us to determine this thing called slope and write equations and graph equations. Okay, so I hope you guys have a great day.